So for this project, we're talking about the portfolio optimization based on the Markowitz efficient frontier and the Sharpe ratio here. So we are two members in group 3 working on this project. So my name is Yuqing Shi, who is an undergraduate student, senior, majoring in applied mathematics and statistics. So I'm a double major, and this is my first year at UConn.
Hi, my name is Chen Wang, and I'm a graduate student. This is my first semester here in UConn, and my major is applied financial mathematics.
So this is our main objective for the project. We're going to focus on the portfolio optimization based on the Markowitz efficient frontier and Sharpe ratio. So here's a brief background introduction. We find out from the brief history about Harry Markowitz published his paper, Portfolio Selection, in 1952. This paper earned him a recognition as a pioneer of modern portfolio theory and eventually led him the winning of the Nobel Memorial Prize in 1990. The overall idea for optimization is that investors want their portfolios to grant them with the highest possible returns for any level of risk that they may be willing to take on here.
When it comes to investment, MPT follows the following assumptions, which are investors are rational and risk averse, and they want to maximize their expected returns, and commission and taxes are not considered in this case. And all investors have access to the same information source, and all necessary information is related to investment decisions. Investors can borrow and lend funds at risk-free interest rates without restrictions.
So here's the basic principle of this theory here. So the effective frontier can maximize the expected return at a specific risk level. The investor with low tolerance will choose the portfolio that can provide the maximum return under the lowest risk. And vice versa, that investors with high tolerance will choose the portfolio that can provide the maximum return under the highest risk. So each point of this represents an optimal combination of stocks maximizing the expected return for any given level of risk. Other dots shows portfolios with an inferior of portfolios on efficient frontier, but will with a higher risk.
Yeah, naturally. Okay. If all points on the efficient frontier curve are the optimal portfolios, we still don't know which is the most optimal portfolio in all these optimal portfolios. So we need another criterion that allows us to choose the most optimal portfolio. And William Sharpe extended Markowitz's work and developed the capital asset pricing model, which we called as CAMP. We only use one of his achievements here, which is Sharpe ratio, as the criterion for selecting the best portfolio. Here on your right hand, we have a formula for Sharpe ratio. Sharpe ratio is equal to the subtraction of expected portfolio return and risk-free rate of return divided by the portfolio standard deviation. Sharpe ratio can be used to measure the performance of investment returns under specific risks. This ratio adjusts the return of investment so that we can compare different investment performance under a certain scale of risk.
So this is clearer interpretation of the MPT by visualization. So the MPT actually stands for the modern portfolio theory, which is how the investor risk aversion constructs portfolios to maximize the expected returns at a given level of risk. The MPT hypothesis emphasizes that investors have additional risk, high returns, only when higher expected return is possible. So the different stock portfolios produce different expected returns here. So this is a graph that gave a more clear picture. So each point on this line represents an optimal combination of securities that maximize the return for any given level of risk. So this is the standard deviation from low to high of the risk. And these dots, although they're not really important, but they represent the portfolio that are inferior to the portfolios on the inflation frontiers. They either offer the same returns but with more risk, or they will offer less return for the same risk. This is kind of similar for the first picture we showed.
Okay, here's our methodology. To first we need to select the data. To access the data, we use the financial platform Condo, which offers a Python library. We also import other libraries to select and reorganize the data we are going to use. Here, we choose to select the data from the first day in 2016 to the last day in 2018, because this gives us more rows and data to analyze. And here we randomly pick 5 stocks to form a portfolio. You can see the ticker in the selected list.
So here's the results of last code, which we selected the 5 stock, which is called CMP5, GE, TSLA, and WMT here. So according to our results, we simulated about 10,000 portfolios of different stock portfolios. Practically, the risk-free risk of return is generally the yield to maturity of risk-free bonds issued by the government with very low or even negligible default risk here.
As mentioned in the last page, so here we choose to use the 1-year US Treasury yield as the risk-free rate of return. So here, first we created 4 empty lists to store respectively the portfolio's returns, Sharpe ratio, volatility, and weights. Second, we set the number of portfolios to be generated and create loops to populate those lists with all these 4 items. When this is done, we will create a portfolio to store the list of portfolio returns and risks and expand it to accommodate the tickers and asset weights in each portfolio. Next, we create a data frame from our portfolio, and then we will be able to draw a color chart with the value of Sharpe ratio. The code would be followed on your right hand. You can just pause and read it.
So here is the optimal portfolio code and the output over here. So actually the code is just we're trying to get the volatility minimal and the Sharpe ratio here. So we're just gonna utilize this to find the optimal portfolio and the portfolio with the lowest volatility, the preference portfolio of the investor with the most serious risk aversion. And according to the results, where there is just like the blue and the red dot over here, and I'm going to explain more about what it is. So the red one is the Sharpe ratio, and the blue one, I believe, is the variance over totality. So we're trying to just print out the minimal variance part and the Sharpe portfolio from the last graph. And we find out that the two type results show that the investor with the most serious risk aversion will choose the minimal variance portfolio with an expected return of 8.72% and expected the volatility of 12.77%. So the investors pursuing the maximum risk adjusted return will build a portfolio with the maximum Sharpe ratio with an expected return of the 20.45% and an expected volatility of 14.12%. Thank you for everybody's patience.
好，暂停。